Let us now understand how knife Bayes works. So look at this example here. We have a dataset with some features: outlook, temperature, humidity, and windy. And the target here is to predict that whether a person or a team will play tennis or not. So I'm representing all the features here with capital X and the classes here, which is class 1 and class 2, as yes and no with C of K. So in knife Bayes, for every observation, we determine the probability that it belongs to class 1 and class 2. So for example, here we'll first find out the probability that the person will play given the humidity is high, temperature is hot, it is not windy, and the outlook is sunny. And then we'll also calculate the probability that the person will not play given the same conditions. And this is repeated for all the rows. So for the second row, we'll again calculate two probabilities. First, the probability that the person will play and the probability that the person will not play based on all these features. So this is in a way calculating the conditional probability where we try to predict the class based on the conditions or the features here. So recall the formula for conditional probability. In this case, we have the probability of E1 for a given condition E2. Based on the problem statement, we can say that the E1 is predicting probability of class 1 and class 2 based on the condition that we have all the following features here. So when I write the same in the terms of classes and features, I will get a formula something like this, where we try to predict the probability of class C1 and C2 based on the features X. So we can say that the probability of target CK given the features X is equal to probability of the features given the target into probability of the target and complete divide by the probability of features. Now we have two classes and four features, remember. So if I write this formula for class C1, I will get it in the following manner, where I replace C with C1 and X with intersection of X1, X2, X3 and X4. You might have a question as to why we take this intersection. This is because we are denoting that all these conditions happen at the same time. So at the same time, when the outlook is sunny, when the temperature is hot, when it is windy and the humidity is very high, when all these conditions happen at the same time, we want to predict that a person will play or not. Now the knife Bayes algorithm assumes that all the features are independent of each other, or in other words, all the features are unrelated. So the temperature being hot or the humidity being high or the weather being sunny is independent of each other. And with that assumption, we can further simplify this formula and write it in this form, where we determine the probability of x1 given c1 multiplied by probability of x2 given c2 and so on. This will depend on the number of features that we have. So this is the final equation of knife Bayes, and we have to calculate the value of probability of C1 and C2 for both the cases. So we calculate the probability that a person will play and the probability of that the person will not play based on the given features. Whichever of these probabilities is higher is taken as the final class. In this video, we'll discuss the different types of knife Bayes algorithms. So we have three types: Gaussian knife Bayes, multinomial knife Bayes, and Bernoulli knife Bayes. Let's talk about which of these is used when. So, firstly, let's look at Gaussian knife Bayes. Now, this is used when the variables are continuous in nature, and the Gaussian knife Bayes assumes that all the variables have a normal distribution. So, in case you have some variables which do not follow this property, you might want to transform these variables and make the distribution normal. Now, the next we have is multinomial knife Bayes. This is used when the features represent the frequency. So, if suppose you have a text document and you extract all the unique words and create multiple features, where each feature represents the count of the word in the document, in that case, we have frequency as the features, right? So, in such scenarios, we use multinomial knife Bayes. Multinomial knife Bayes ignores the non occurrence of features. So, if you have a frequency 0, then the probability of occurrence of that features comes out to be 0, and hence multinomial knife Bayes ignores that feature. And it is known to work well with text classification problems. So we'll also implement this algorithm on a similar example. Now the third we have here is the Bernoulli knife Bayes. This is used when the features are binary. So instead of having frequency of the words, if you have suppose ones and zeros, that is discrete features which represent the presence or absence of the words in the document. In that case, the features would be binary and you'll use Bernoulli knife Bayes. So this method would penalize the non-occurrence of features. Unlike multinomial knife Bayes, this method penalizes the non-occurrence of features. So now that we know which technique to use when, let us look at some advantages of knife Bayes algorithm. This algorithm is easier to build and simpler to understand, and it is much faster than other algorithms since it is not calculating the interaction between features or the combination of features. Instead, it's just calculating the probabilities. Knifebase is also easily scalable and hence is widely used in the industry, and it is a popular choice for text classification problems. So, if we talk about some of the application of Knifebase, the most common use of this algorithm is for the real world apps where we need to respond to the user's request instantly. So in that case, knife based algorithm is used. And some other common applications that you might come across would be predicting if a mail is spam or not, or classifying the documents, and also even in sentiment prediction problems. Now, there are some important points that you should keep in mind when you implement the knife based algorithm. First of all, knife based assumes that all the features are unrelated and the features are independent of each other. So, this algorithm would not calculate the interaction amongst the features, and that might be a drawback. Another important thing is when you use Gaussian knife based, the knife based algorithm assumes there that all the continuous features have a normal distribution. Another important point is that when using multinomial knife base, as we discussed, the algorithm would ignore the non occurrence of features. So, ideally, if you have features with the frequency 0 and if you have too many such features in your data, a suggestion would be to add 1 to all the frequency values. So, in that case, you would not have any frequency to be 0. And finally, you should take care that you do not have highly correlated features in your data because knife based algorithm calculates the probability for each of these features, right? And highly correlated features will be counted twice.